For next 30 minutes, right, we're just going to focus on Aperture. I'll go through the agenda in a bit, but think about we all have insurance of some sorts, right, either for our car or for the house, because at some point we do realize something might go wrong and you need some sort of insurance, right? How do we provide similar assurance for our applications, right? When a performance degradation starts, what sort of assurance you have that the application will stay online, there is no cascading failure. So quick agenda, discuss overload for a single service, right? Within the application, if we had to zoom in, how does overload happen for a single service and the impact that it causes on your application? Then jump into benefits and kind of the disadvantages of concurrency limit, right? What are the challenges you run into when you define concurrency limits? After that, obviously, introduction into what Aperture does, all the capabilities of Aperture. And I will close it out with a real-world example that few of our clients are using on kind of how to do intelligent load management. So that's kind of the last use case I'll close in with. So understanding overload, I'm pretty sure all of you understand it, but just going back to the basics is, hey, when things are great, the diagram on the right, there are enough seats on a plane, life is good, number of passengers are less, everything goes well, right? When the number of requests suddenly spikes up, right, that's when latency goes up and you start seeing timeouts, right? We can do a lot of load management, load testing in our kind of the test dev environments and figure what is that throughput of that particular service, right? What can it handle by doing some sort of load testing? But the number of requests any service can handle depends, there's a finite limit because it depends on the underlying infrastructure at that point in time, right? So it has that becomes the bottleneck. And based on that, you need to figure out what that concurrency limit needs to happen. If you look at the details of any service, right, no matter how complex a service is, if you apply Little's law to that particular service, you can figure out how many requests it can handle, right? Think about, and the simple formula of Little's law is number of requests in flight is you multiply average throughput by the average response time, and you should be able to figure the throughput that the service can handle. Now, if and when the limit is exceeded, that's when timeout happens, the performance degradation starts, and you start seeing latency spike up, right? So if you take this real world scenario where the throughput is kind of the x-axis, the latency and availability on y-axis on left and right side respectively, at 50%, as soon as latency reaches the client timeout, right, you start to see the availability go down for that particular service to 50%, and eventually it drops down to 0% after that. So what causes these overloads, right? You guys can preach me more than a year. We all have gone through this scenarios. The first one is traffic spikes, right? Think about retailers, the Black Fridays of the world, Walmarts and all the retailers have those Black Fridays. They're expecting 1 million users and suddenly 10 million users show up, could cause that cascading failure. We all know as developers, we do feature rollouts, add capabilities, and there are bugs that get introduced that also causes some sort of cascading failure in your application. Third-party services. I'm sure all of us are using some sort of third-party service. Even GitHub has quotas, for example, right? So when those quotas are reached, it could have a reverse impact on your application, and you can start seeing timeouts from there on. Retry storms, it's kind of a, if you research about that, it's more about a meta-stable failure, right? That's what retry storm is caused for, right? When the application gets overloaded with a small spike, right? The spike can cause a retry storm. People will start browsing, refreshing their website, and suddenly you have this retry storm. Even that small spike has passed away, but the retry storm will cause a cascading failure. So pretty common out there with the customers we have been working with. and experiencing retry storms. And last two are more localized. The cache failure, if a database fails or number of servers go down, kind of the load goes, the load increases on the remaining servers that are online. So the intent is the fire is going to happen. How can we use Aperture to not make it a wildfire, right? That's kind of the end game we are trying to achieve here. So with concurrency limits, right? Service is great. Anything access. So when the latency spikes happen, when the SLO is violated, we can start doing load shedding, right? That's the true reason of doing concurrency limiting for any services, any additional load that is causing spikes. You can start load shedding or load scheduling at that point in time. So in that scenario, if you apply the concurrency limit in a right way, you should have your availability that the service supports all the time, right? Because all the excess traffic is being dropped in a very smart fashion. So let me get into Aperture, right? But before that, I just want to say is defining concurrency limit has its own challenges, right? It's not an easy to do thing because of the dynamic nature of the application itself, right? In this microservices world, as you saw the failures early on, the number of users can spike up, the software bugs can spike load. So how do you define concurrency in real time, right? That's the biggest challenge that Aperture can help you solve. Second is, what is the right limit? If you configure concurrency limit way too low, you might have resources that can support additional requests, but because you have defined it too low, you're wasting your resources. Or if you set too high, then you're kind of declining your user traffic at that point in time. So adjusting that concurrency limit in real time is one thing to keep in mind. And second is the services are interacting with each other, right? In a distributed fashion across clusters. How do you define concurrency across those shared resources? Or how do you define a concurrency limit when you trigger autoscale for that matter, right? So all of these things need to be considered before you go and really define a concurrency limit for your service. And obviously, while your application is online, while the load shedding is happening, how do you look into the observability part of it, right? Is the load shedding happening in the right fashion, right amount of time, and in the right places? All of that needs to be visualized. Along with concurrency limiting, there is this whole notion of defining workload priority, right? How do you smartly define workload priority at scale? And thinking about that is, if you let requests come in, you need to know what is the cost of that request, how much that request is going to consume what resources at any given point in time, right? So you define a priority, understand the cost of that particular request, and then decide what do I load shed or not, right? And a simple example is your paid user is more important than kind of the guest user or subscriber at that point in time, right? So who do you give more priority when a performance degradation starts? So jumping into Aperture, it's open source. So I have the link at the end, but Aperture is our open source platform. So I'm not here to sell anything. It's all, you can go to GitHub and start using it today. The inspiration, what we got was around Tesla, right? If you think about what Tesla has done, it has combined observability. It is looking at the car in front of you, the distance, do you need to accelerate, brake, combined with control systems theory is what it has done, right? It has closed loop automation as part of it. And then that's how the autonomous driving works. That's what we have kind of got inspired and said, hey, we have our own observability layer. We need to look at service interactions, the incoming traffic, and based on the configured policy, what all actions do we go and perform? Obviously, what are the features that we have currently available within Aperture? One is classification. So we have a classification rule that you can define where you can say, hey, these are the custom labels or tags I want to go understand in my traffic, right? At ingress point or egress point for every service, you can define a classification rule. So it lets you know what traffic is coming in. And that also helps you decide who gets priority, right? Which labels get priority, which don't get priority. Then we have a declarative policy language. So it's control systems, or think about building a circuit, right? That's what our policy engine is, where you can define multiple actions. The output of one action is the input to the other action, and that way you can, in my example I'll walk through, you can define multiple actions to run at any given point in time for a particular service. There are multiple actions you can take, the 5 of them: load scheduling, rate limiting, quota management, and dark long feature rollout. I'll get into this later on. And it has a Grafana dashboard. So Grafana is bundled in, so that way you can get real-time insights and analytics down to individual signal, right? You can get performance matrix for any signal that you have that you want to monitor on, and that helps with debugging or understanding why that performance spike happened, and based on that you can do corrective action at the next time. So what are the internals, or kind of the 3 key components that make up the architecture for Aperture? The controller up left is kind of the brain, right? Which is where the policies reside. And the policies are nothing but you can manage it through Kubernetes custom resource definitions. The controller is looking at all the deviations happening, right? It's monitoring all the telemetry data per service and understanding what all deviations are happening based on the policy you have defined. And once the violation occurs, it will notify the agent. So agent's the worker bee, which you see at the bottom, where it will ask the agent to start doing load scheduling, load shedding, or even autoscaling, right? The agents interact with Kubernetes APIs and also can perform autoscale at that point in time. There are 2 databases, Prometheus and etcd. So if you have your own Prometheus instance, we can definitely integrate with that. But Prometheus is where it's the OLAP database where all the telemetry data is residing. And on the etcd side, it's a key value store, understanding all the labels, mapping it with the telemetry data, including all the policies that the controller has is being stored in their etcd. So what are the use cases and scenarios if I had to combine them, right? So this is the example. Think about application with 3 services, right? You're monitoring a downstream service in this example, which is service 3. And FluxMeter is our language where we combine the labels with the matrix, right? So let's say I'm looking for my paid users is the label, all the matrix associated with that becomes a FluxMeter for us. Now, you can start designing a complex policy. The top one is, hey, let's say I as a developer am going to roll out a feature, right? How do you do load ramp up at that point in time? Because you don't want 100% of the traffic going to that feature from day one. You want to stagger it and do a controlled ramp up. So we have an action called load ramp or load shaper, basically, which will let you say 10% of the traffic for 2 hours, or these are all variables that you can change around, and say, let 10% of the traffic go to this new feature that's been deployed. If things are running fine, slowly ramp it up to 20% after X duration. And if things go fail, reset back and disable that feature flag. So that's some of the use cases. That's actually the most used use case from our customer base. The second use case we are seeing is third-party scenarios. Now, there are 2 ways to think about third-party scenarios. One is, if you are using database as a service or some third-party service, how do you take that quota and understand your concurrency limit, right? Kind of reverse engineer it back and try figure out what is happening. So that's where you can use some of the custom policies that you want. Or if you are giving some of the services to your clients, right? You don't want your partners to abuse that quota. So you can do abuse prevention and say, hey, for partner A, this is kind of the request per second. Partner B, this is request per second. That way, a single query from your external partners doesn't bring down the service. So you can do smart policy management through that also. The third scenario, which I'm showing here at the bottom, is a lot of cases, at least talking to a lot of our customer base and other partners of ours, things are done in silos, right? Either you're doing rate limiting or autoscale is kind of the answer from a lot of our customers saying, hey, we just autoscale, whenever a performance spike happens. But all of them are done in silos by one team, not even talking to the other team, because just the way the teams are being structured. In this scenario, you can define an action where it's saying, hey, do rate limiting, concurrency limiting at the same time. So you can have these actions being performed at the same time, saying, dynamically figure out what my rate limit is. And while that is happening, if my latency spike still continues, drop this priority-based, do priority-based load shedding also at the same time, right? Where the paid users get higher priority and unpaid users get lower priority. And if still everything's failing, in parallel, go trigger autoscaling. So that way you have these globalized control everywhere that lets you go and control any upstream service if a performance degradation starts in a downstream service at that point in time. Again, it can be used in silos. So if you just want to do rate limit, you can do that also. But we give this globalized approach where you can mix and match the actions that you want to perform on any given service. With that, just the links, the GitHub link, which is there. In case you want to see a demo, we have you can schedule a demo to see Aperture in action, and then our playground also. It's a pretty simple. The service that I showed you, 3 service application that you can download and play it out and start playing with the policies also that I showed you. With that, I'll open it up for Q&A for the next 10 minutes. Yeah.
Great.
Thank you.